Hi, my name is Hyder Abbas. I welcome you to one of the most potent course when it comes to unit testing with JUnit5 testing framework. I'm here to make you proficient developer with a strong skill set of JUnit5, which is important for Java developers. Before we get into using JUnit5 testing framework, let me give you brief overview about this course. To start with, in order to understand unit testing, you should have knowledge of Java. I'm not expecting you to be Java expert. However, from beginner to intermediate level of knowledge is required in order to proceed with this course. Now, you know Java, you will be in a position to understand JUnit5, which is the latest testing framework for unit testing. You will learn both theoretically as well as practical, and of course the more focus will be on the practical aspect of using JUnit5 testing framework. However, we will also understand some theoretical part to have a strong foundation about unit testing. You need not to have any prior knowledge of unit testing or testing, as we are going to start this from absolute scratch. If you could able to watch all the lectures which are part of this course, at the end you will have strong hold of how to use JUnit5. You can also call it as JUnit Jupyter testing framework for unit testing, which will make you industry ready. If you want to complete this even more earlier, you can also watch the entire series in 1.25x speed or 1.5x speed. Having said that, let's get started. Hello and welcome back. In this video, we will try to understand about unit testing and how unit testing is different from usual testing of an application. Whenever you hear testing in the software development ecosystem, testing referring to something which is done post the development. That means testing of an application which you have developed and usually done by a separate dedicated team of testers, or you can say test engineers. Different companies, different designations, we call them QAs, software development in testing, test engineers or tester. Unit testing is also talking about testing the application, testing the functionality of an application only. However, this is something which is done by software developer itself. That means the one who is developing the code, the one who is writing the code, he will only perform unit testing. Exactly how different they are, we will try to have an idea about this. To start with, whenever we have any requirement in front of us, any problem in front of us for which we are trying to give solution by developing an application, usually we go through with software development life cycle, SDLC, and I don't want to get into the entire development life cycle, but typically what we do is, based on the problem we have in front of us, first we go for the designing. Before we develop the solution, before we write the code, first we design, and based on the design, then we develop an application. That means then we write a code. That means coding is being done here. And once coding is done, once the development is done, then we will perform the testing. Testing of an application, whether it is working fine as per our expectation. Now, whatever testing is talking here, it is different from the unit testing. This testing is usually done by a separate dedicated team of test engineers in a project which they are involved in, and this is done post the development. That means maybe you have developed the web application, so many classes, so many files are involved there, and you will create a var and then you will deploy. Once it is done, then you will go to the specific feature, specific functionality of an application manually, and you will perform the testing whether it is working fine or not. And if there is any problem, then they'll raise a bug, and then developer will try to resolve, which usually developers don't like it. But however, this testing is totally a different and this is the traditional way. Once we develop, that will be tested later by a separate dedicated team of test engineers. Now what unit testing is talking is, this is done when you are developing the application, while you are writing the code, and this is done by a software engineer itself. Now what do we mean by that? Let me just open this code file here. Now in this code, maybe whenever you develop an application, there is a possibility of having so many classes, and in those classes we may have so many methods, and one unit is referring to one method of those many classes. Example, one unit, one method I'm writing. Usually we write methods to write some behavior, to execute some behavior, and this one method I can call it as one unit of an application. It need not to be only one method. Sometimes in a bigger application, a group of methods can be called as one unit. A group of classes can be called as one unit of an application. Example, we may have 100 classes in our application, and that 100 classes you can divide maybe in 20 units. So maybe 5 classes in one unit. So sometimes unit can be referred as group of some classes based on the behavior and feature they are trying to develop or they are trying to execute, or maybe it could be sometimes a group of some methods. But typically, generally, we refer unit means one method, because inside a method some behavior will be there, some functionality will be there, some task you might have written, and testing this one task is all talking about unit testing, and this will be done by developer at the time of developing. So what we usually do is, first we write the test. Based on the test, we develop a specific unit, and then we will run the test whether it is passing or not. If it is successfully passing, that means this unit you have developed perfectly. If it is not passing, then this unit you have not developed. At that instance itself, you can perform the modification. If your test, whatever test you have written, if that is failing, and you can modify that unit at that instance itself. And whatever test you are writing, it is not just for that specific time, that will be there for the future also. Example, I have written the test, right? Based on the test, I have developed this specific unit, fine, and now it is passing successfully. That means this unit is working fine. Now later maybe I develop few more functionalities, I will add few more units. That means I'm writing few more methods, maybe 3, 4, 5, 6, 7 methods I have added, and for everything I have written the test. At that instance also, again the same test which you had written for this particular unit, that also you can execute. That means if I add some other methods, if I add some other features, is this old feature, this old method which I have written, is it getting affected by the new methods which I have added or not? You can cross check by writing the same test which you have written earlier, fine. Or maybe by chance all of a sudden someone comes here and try to modify this particular method which you had developed, and then if you run the test, it will fail. Making sense? So what I'm trying to say is, this test you are writing for a specific unit, it will have impact at that particular state also, at the particular moment also at the future. That means the same unit, the same test which you have written can be used and again to test your specific unit of an application. So unit testing basically talking about testing your application in units. So one method, one unit. I'll develop a test, and I will write the code based on the test, and then I will run my test whether this particular unit functionality is working fine or not. And this is totally different from usual traditional approach of testing an application, which is done after developing the whole application. If it is a web application, so many classes I have, then I'll create a var of that, then I'll deploy, and then that will be tested by software test engineers. That means testers. But here it is something which you as a developer are going to do it. I'm going to write a test. Based on that, I will write the functionality, then I will check. And how exactly it will happen, how can we use JUnit, that we will understand in upcoming videos to get more clarity on this. Hello and welcome back. Consider the application which you can see on your screen, wherein I have developed one basic application which consists of 2 units, 2 methods, and I want to test these methods or these units, and testing this one unit is only called as unit testing. In order to test this particular method or a unit, in industry, we use one of the most popular testing framework in order to perform unit testing, which happens to be JUnit5. However, can I perform unit testing without having to use JUnit5 or any other testing framework? Yes, you can do that. And that's what I'm going to do here. Suppose whatever method I have developed here, I want to test it. In order to test that, first you need to prepare. How can I invoke this method? What type of data I may have to pass in this method, and whatever is required in order to invoke this method, you may have to make an arrangement. Let me write the test here in order to check this development which I have done here. I would go to the main class. First, I have just created the instance of that calci class, because the method, that unit, is an instance method, non-static method. If you want to invoke that, I may have to create the object. This is also part of the preparation. Then I will pass the input to that particular unit, to the particular method. So I'll use the reference here, and then I would like to call that method, and later I would like to pass some data. Maybe I'll pass some input here, 10 and maybe 5. Fine. Now if I run my test, this method will get executed and it would return me some result. That result I would like to collect it here, maybe integer type result. And this method would generate the actual result. That means whenever you have developed a unit and when you test that method would give you some result, and whatever result that method is generating, that can be considered as the actual result which method is generating. And now whatever actual result I have got from the method or a unit which I have developed, I would check with the expected result. That means what is my expectation, by keeping what in my mind I have developed that particular unit. So I will just verify it. In other words, I will perform the assertion here. Assertion means I'm just trying to verify, is it matching? Is the actual result which is generated by that unit, is it matching with my expected result? And based on that, later I would report the result to the developer, whether the test case has been passed or not. That means if it is not matching, if it is not generating the result which I'm expecting, I may have to alert the developer that your test case is failed. You may have to again work on that particular unit. Let me do that here first. I will say here, if in case result is equal to 5, maybe 2, 10 by 5, or maybe 2. If it is 2, then I would alert my developer. By telling whatever test case you have developed, that is passed. I'll say here test case is passed. And else if it is not, then I will say here I would alert my developer that test case is failed. Fine. That means this I'm verifying, and based on the result which I have got, I'm just alerting my developer whether whatever unit he has developed, whether it is passing or not. So let me run this application. So this test case is passed. Now I will check with multiple types of input. That means multiple test cases you may have to write. Again, I would like to write one more test case here based on a different type of input. And maybe this time I would like to give here 0. And maybe it is result 2 or test case 2. And now I will check whatever test case 2. That means if I run that particular method, it would give me some result. And based on that, I would collect it here. I'm checking, is it matching with my expectation? If it is not mapping, that means the test case is failed. And this is how we perform unit testing manually without having to use the testing framework. I hope you got one basic idea about it. So let me just brief over it. These are the steps which we have followed for unit testing. However, out of all these steps, some of the steps would be common. Example, running the test, performing the assertion, alerting the developer based on the test case, whether it is passed or not, would be common. However, for every unit test, all these steps are necessary, but they may differ based on the type of unit you are working on, you are performing testing on. Example, if you have a unit, we may have to prepare differently for a different unit. Maybe one unit is a normal instance method. If you want to invoke that, we may have to create first instance of a class, then we have to invoke. Example, we may have another unit which is a static method. In order to invoke that static method, object or instance of a class is not needed. Directly with the class name we can invoke. So what I'm trying to say here is every unit we may have to prepare differently. We have to do preparation but in a different way for different units, and we may have to provide the input to the unit differently for different units. Every method may expect different type of input. Based on what it is expecting, you may have to provide that. Based on what type of operation you are performing inside that unit, based on that you will be giving the testing input. So in general, providing the testing input is common, but the type of data which you will give as an input may differ for different units. And of course, based on the activity which that particular unit or a particular method is performing, you may expect a different result. In general, expecting a result or output is common, but the type of the data which you are expecting from that method may differ from one unit to the another unit. But however, running the test case is common irrespective of the type of the unit or irrespective of the type of the operation which you are performing inside the unit. Performing the assertion, that means verifying the actual result and the expected result. This is something which is common irrespective of the type of the activity which you are doing inside a unit. Inside that method, you may have to verify based on what type of input you have given. What is the method generating, what result method is generating, that is the actual result, and we will again have to provide the expected output, what I am expecting, and based on the actual result and the expected result I may have to verify, and this is common irrespective of the type of operation that method is performing. And later reporting the test result, that means alerting the developer. And manually we have used bunch of system.out.println in order to alert the developer whether the test case is passed or failed. However, in these cases, testing, running the test, verifying the result and alerting the developer, these are common steps irrespective of type of operation which a particular unit is performing. And here is where JUnit comes into picture. In place of manually testing unit, if you use testing framework which happens to be JUnit5, you may just have to prepare, and based on that you may just have to provide the input to a method and you may just have to provide the expected output. JUnit will take care of running the test case. JUnit only will perform the assertion. JUnit only will verify is the actual test matching with the actual result, matching with the expected result, and JUnit its in own way will alert the developer whether test case is passed or not. You as a developer need not to worry on that. You as a developer need not to write extra lines of code in your test. You just have to give the input, you just have to give the expected output. Rest of the things JUnit5 will take care of it. And to perform the assertion, we have a lot of APIs. It's not just it's more than performing the equal operation. Whatever we have done right now in the code manually to perform, we were just checking whether this is equal to this or not. It's more than that. We have a lot of APIs while performing the assertions. With JUnit5 will take care of this. And once we start with this testing framework JUnit5, you will have more idea about how exactly we may have to go here. If you use testing framework which is JUnit5, it will make your life easy whenever you want to perform unit testing. And how it will help you, eventually you will see in upcoming videos when we practically use JUnit5. Now it's time to get into JUnit and create our first Maven project, for which I have opened Eclipse IDE. You can choose any IDE of your choice, but make sure you should be in a position to create Maven project. Why Maven project? Because it will provide a specific structure wherein using which you can easily write test by using JUnit. It expects us to use follow one specific structure, and Maven will provide to us. And however, in the industry also we are going to use such build tools. Even if you don't know, I would be guiding you how to create a Maven project. Now I have opened the Eclipse IDE here, and if you have opened Eclipse IDE in the Java's perspective, this is how you have to create it. File, new. You will not have any option of Maven project directly here. If you have opened the Eclipse in Java EE perspective, directly you will have an option of create new Maven project. Since I have opened in Java's perspective, I do not have any direct option. I'll go to the others, and in there, Maven project, next, and create simple project, next. Group ID, some entries it is expecting us to pass, we may have to enter that. Group ID is similar to what we give the convention for the package whenever we create a simple Java project and we create packages within which we write the class. Something similar here. I'll give the package name as maybe Telusko learning, whatever you would like to give. And artifact ID, the name which you would like to give here, I'll give here JUnit 01. Finish. Now our Maven project is ready. I'll just scroll down. You can see here, and now you can see source/main/java. Here is where we actually write our project. That means for our application, whatever classes are needed, whatever files are needed, we are going to create here. Here is where we develop our application. However, the test which we are going to write is in the source/test/java. And this is the beauty of Maven. Maven will give you this structure. So I now want to mix my test files into my project file. So project file should be independent of whatever test I am writing here. So I am going to create the test here in the source/test/java, and actual classes which are involved in my project I am going to create here. This is how we use Maven here. So let me just create, and before that I'll go to the pom.xml, and since I'm going to use JUnit, I'm going to ask my Maven, please add JUnit libraries to my project. If you don't use Maven, then you have to do it manually. Manually, you have to download all the libraries or jar files, and then that jar files you have to add into your project by your own. Since I'm using a build tool, Maven, I'll make my Maven to do that for me. So I'll just go here and add one tag called as dependencies tag. And within the dependencies tag, I'll go to the Maven repository. I'll browse to the the browser of your own choice. And once I have browsed here, you can just search Maven JUnit repository. You will be open Maven repository, www.mavenrepository.com, and there you can see testing frameworks and tools. If you click there, you'll have so many options. The first option, JUnit, I'll click that, and any of the version, I'll click this, and you can see the dependency. It's like the way we are informing the Maven to add the dependency, required jar files into our project or required libraries. And the moment I save this, you can see Maven dependency. That means all the required library files Maven has added to our project. We need not do something explicitly. This way we are just informing Maven that please do this need for us. I want to use JUnit. Could you please add JUnit library to my project? Maven is like, okay, I'll add, and you can notice here Maven dependencies. Fine. And scope, by default it is test scope. That means whatever test I'm going to write, I don't want that to be added in the deployment. That means once I develop my project, I deploy, I don't want this test also to be deployed. It is just for me. When I develop, just to check my units, I'm writing the test, not for the deploying purpose, not to deploy all the tests which I'm writing for the applications. So what I'm doing here is like I'm just specifying scope. That means it is just for the testing purpose. For me as a developer, I want to check my units only for that. However, anyway, the dependencies I have added. Now I'm going to go and create a new project, whatever project, maybe simple project, just to show you this. I'll say here maybe calci, and the package, let it be com dot Telusko dot, and maybe I'll say here learning or JUnit, whatever name you'd like to give. And I have a class here, and I'm going to develop a unit within this. I'm going to specify here public integer type, whatever method you'd like to give. Maybe I'll say here divide, and within this integer type maybe number1 comma integer type number2, and here I will say here return by dividing number1 by number2. It could be anything else. We are going to explore so many units, we are going to explore so many projects. To start with, one basic unit we have in my application, and I would like to test it. Fine. Now, how do we write the test? As I have told, test you need not to write in the actual project, actual application. You have to write inside this. So I'll right click, new. You can have an option of JUnit test case. JUnit test case, and whatever is the name, actually whatever the class name where the method is, the unit is residing, that name. It's a convention to give test. However, before doing that, I'll say class under test. I will not specify directly here. I'll say here class under test browse, and I would like to specify here calci, and click this. I'll say here okay. Oops, let me just calci, no problem. Browse it and okay. Give the name as calci test, and the package must be same as that you have given there. The other way, the easier way to do that also there, by using the Eclipse ID. I'm doing it manually. I'm just creating the test manually, but usually we don't do that. We have an IDE which will help us to create the test. I'll give the package here, the same package which we have given for this class, and the class name followed by test. The test name you can give anything. In fact, you can give your any name of your own choice, but it is recommended which unit, inside which class that unit is present, followed by test. It's a convention. Whatever name you want you can give, but it's good to follow this structure of naming the test. That's it. So after which I'll say here finish. Now my test is ready. Fine. So let me run the test. I'll see here right click, run unit test. You can notice we are getting the red. It's failing. That's fine. We will see how to rectify that. But however, we are able to run the test. So what I'll do here is fail, pass. We will see that later. So I would like to just run one message here. Maybe first JUnit run. Okay, maybe first unit JUnit run. One message I would like to give into my console, and now I would like to run that. That means we are able to run our first test which we have written. However, I would like to also show you how do we create this without we having to create separately. So what I'll do here is, you can see here, maybe I would like to delete this. Okay, done. You can just click on the class inside a unit is residing, and I want this unit to be tested. I'll just say right click, new. You have an option of JUnit test case. I'm using the IDE in order to do that. Now see, everything is filled here. New JUnit4 test. I know we have to learn JUnit5. However, initially I'm just trying to show you how to use JUnit testing framework for unit testing. Of course, we will also see how do we actually create test for JUnit5 using JUnit5 testing framework. For now, just using the JUnit simple. So next, see, the test is ready. You need not to do that explicitly like we have done previously. Just click on the class new JUnit, it will only create it. And of course, it is not running the way we are expecting. We will rectify this in upcoming videos. This is the setup for the first JUnit. Now the required setup is ready. Let's just run the first test. Let's use JUnit for the first time in order to check whatever unit I have developed, whether it is executing as per my expectations or not. I would just go through the unit. One basic method I have here, which will just divide two numbers. So if I execute this method, whatever output, whatever result I'll get will be considered as actual result. That means if I execute this particular unit, this would give me some result, and whatever it is giving me, that is an actual result. And there is something called as expected result. That means as a developer, what I am expecting. So maybe if I have to divide 10 by 5, my expectation is 2. And if I run this method, if it is giving me 2, that means my expectation is matching with reality. My expected result is matching with actual result. In that case, the test will be passed. Suppose I'm expecting 2, and if this method gives me maybe 4, then the expected result is not matching with the actual result which this method is generating. Then the test case has to be failed. For this basic unit, let me just create here. So you just have to use one method here. That means you're just going through the assertion. Assertion means you're just trying to verify the result. So what I'll do here is I have to use one of the method. I'll say here assertEquals, and within this, maybe I have to pass first the expected result and then what the actual result it is giving me. So for an instance, if I have to call this method, let me just, before I actually do with respect to my unit, I would like to give one basic method here. Maybe expected is Java, and the method is actually which is generating is Java. Now consider this as an expected result. This is what as a developer I am expecting, and this is the result which my method is generating. If that is the case, what would happen? Let me just run this test case. I'll say here run unit test. You can notice the green bar, that means test is passing. So similarly, I would like to do with whatever unit I have developed. So I have to invoke this method. If you want to invoke, this is a non-static method, not a static method. I have to instantiate that class first. So what I would do here is within this, I would like to instantiate the class calc type, maybe C equals to new calc. Instantiation is done, and later I would like to invoke that method divide, and I would like to pass some data, maybe 10, and assume I'm passing just maybe 5. It would give me some result that I'll collect it here in integer type, maybe actual value. Whatever method, when you run the method, whatever it would give you, that will be considered as an actual value. And what is my expectation? Let me run this. I'll say here expected result equals to, maybe I would say here 2. Now I will check here. Is my expected result matching with, it's the API method which I am using. So let me just tell, is it matching with my actual result or not? So let me just save this and run the unit, and you can notice green bar. That means my test is running successfully. Whatever unit I have developed, it is working properly. It is this simple to write a test and run a test. Of course, we will consider many complex examples, and we will explore more on this. To start with, now we are able to run our first JUnit test. Let's create a test using JUnit without having to create Maven project. That means by creating simple Java project. Let me create on my Eclipse new simple Java project. I would like to give the name as JUnit2. I'll say finish. I know what module. As you can see, simple Java project is ready in front of you. Now within the source folder, usually we create all the classes, all the class files which we want to be part of our application. That means within this folder, we will be creating multiple packages, we'll be creating multiple classes which would be part of our entire application. That means actual code of our application would be present here. As I have told earlier, that test file should not be part of your application. That means I have to create one more folder in order to create or in order to write the test. Though here itself, alongside your application class, you can also include your test files, whatever test you are writing. However, it is not recommended. So I'll be creating a new folder here. Right click. I'll say here build path, new source folder, and name I would like to give here as test. Finish. You can see here test folder also have been included. Now within the source, I'll be developing one logic within one unit. So I'll be creating a new class here. New class, and whatever activity maybe, I'll write a logic with a unit which will reverse a string object. So I'll give the class name as reverse string. As you can see on your screen, I have developed one unit, one method which would reverse a string. Whenever you invoke a method and pass a string object, the logic is responsible to reverse that string object. That means if I just pass the input here as Java, and it should reverse this object and give me as this. This is a simple logic which I have developed here, and let's test this particular unit using the JUnit testing framework. So now I'll go to the test folder. I'll see a right click, new JUnit test case, and let it be new JUnit4 test case normal. And I would like to specify here the class name, that is a convention which we have to follow. I'll say here reverse string test, and it should be in the same package. So I'll give the same package name also. So I'll say here com dot. Now let me just say here finish. It is asking add JUnit4 library to the build path. I'll say okay. Now you can see my test is ready. Fail usually we use in order to explicitly fail the test, and I don't want to fail the test here. Rather, I would like to write the assertion methods and verify whether my unit is working or not, for which I may have to invoke this particular method. And if you want to invoke this particular method, then you have to create the instance of this class, because this particular unit is a non-static. Directly with the class name you cannot invoke. So first I would like to just create this class name. Create the object within this method, and maybe I'll give the name as reverse equals to new reverse. Now the object is ready. Using the reference, I would like to invoke the method which is responsible to reverse a string object, and within this I would pass my string object. I have passed my string object as Java. Now this method would take this input and perform the activity to reverse the string, and whatever it will reverse, that object it will return, I'll be collecting here within an object called as string type. Maybe I'll give it as actual object. That means if I invoke the method, whatever actual object, whatever activity it is doing, based on that, whatever actual result it will give you, that is what I am collecting here. What is my expectation? That also I would like to specify here within a variable called as what is expected. I'll give it as maybe expected, and my expectation is here this. So if I invoke and if I pass Java, it should be the expectation. Now by invoking the asserts, I'll be verifying it. Assert equal, and if you just check here as control space, you can see all the methods which you can use here, and we would be exploring many of them. But let me just write here the expected is this, and actually what this particular method is generating me. Let me just run this test and check if it is solving. Let me just say here right click, run unit test. I'll say okay, and you can see green bar. That means the test is running successfully. Now I would write more shortcut here. This is not recommended to write multiple lines, so I'll make it more simple. Instead of calling this method, storing that in a different variable and then passing that here, and expected also directly you can mention here itself. That means you can simplify this code even more. So I'll go here, right click, I'll say here refactor, and there is an option of inline. If you just click here, I'll say OK, and you can see that line has been added here directly. So you can do the same here also, and this particular line will be added here. So I'll say here, right click, I'll say refactor, inline, where that particular local variable is used, exactly there it will add automatically. So you need not to again use those lines. This is simple logic building, but however, using assertEquals method, we are now able to run our test and verify whether whatever unit we have developed, is it giving us a desired result as per our expectation. Now we have done this using simple Java project without having to create Maven project. Now let's write the test using JUnit5 testing framework, which can also be called as JUnit Jupyter. And I would do that using simple Java project. We would also see how do we do with respect to Maven project. Now let me just create a simple Java project, new Java project. I'll give the project name as JUnit03. I'll say here finish. You can notice my project is ready. Now within the source folder, we would be developing actual classes, all the files which are required for our application. My units would be there. If you want, you can also write the test in the same folder, but that is not recommended. I don't want my test to be part of my entire application. I am testing so that the development is good. So for which I would be creating a new testing folder here so that I can write all my tests within that folder. I'll go to my project, right click, I'll say build path. Within the build path, you have an option new source folder. I'll give the folder name as test. Finish. You can see a test folder is ready wherein you can write your test. Now let me just create a new application here, new class wherein I'll be developing the unit. I would like to use the same program which we have developed in the previous video. So let me develop that unit now. Now you can see I have developed one unit here. If you invoke, it should reverse a string. To this particular unit or a method, if I pass this as an input, this should be the result this particular unit or a method should generate. For which I would like to write a test using JUnit Jupyter. So for which I'll go for my test folder wherein I would like to actually write all my tests. Right click, I'll say here new JUnit test case. You can see it is asking the package name must be same as the name you have mentioned for the files, and it is recommended to give the file name also same name as the class name, reverse a string followed by test. You can give some other name, but this is the recommendation. Package, let me give it as Telusko.learning. Now you can see new JUnit Jupyter test. JUnit Jupyter test is referring to JUnit5. Like for JUnit 4 and 3, we have numbers. For JUnit 5, we call it as Jupyter. As we have seen in the architecture, Jupyter API is what? As a developer directly using it. So let me say here finish. Add JUnit file library to the build path. I'll say here OK. You can see my test is ready. Fail method will explicitly fail the test. I don't want that to happen. I want to invoke that particular method, for which I have to create the instance of a method, because this is a non-static method like the way we have done in the last example. Let me just create the object of this. I'll give the method name as reference equals to new, and this is the object I have created. After which I would like to invoke the method dot a method reverse string. Within this, I would like to pass my string, whatever object you would like to pass, I will pass it as Java. Now this method would take this as an input and it will do all the required activity or behavior it will execute in order to reverse a string, and it would return me the result which it has generated. After executing this method, whatever result it will generate, if you want, you can store it in a variable called as string type actual data. This variable name can be anything, since it is executing and giving me the result, and that is what I have given the name as actual. That means actually what this particular method is generating. Let me set my expectations here. I'll say here string type what is expected out of this method, and as for me it should give me this output. Let's see if my method can do that, for which I have to use assertion API. I'll be calling all the methods of assertion. I'll say here assertEquals method. You can see so many options are there. However, I would just use some of the method here, and I like to specify expected actual, maybe the spelling. So I'll say here expected, whatever name you want you can give here. However, these two statements which you have written here, you can directly write here itself. If you don't want to mention it separately for the good readability purpose, you can write it in the same way, or else you can just write it in this way also. So let me just right click here where this actual local variable is used. I want this entire statement to be added there directly. So I'll say here refactor inline. So wherever this was using that local variable, there itself the entire logic have been added. Same thing I would like to do here. I'll say wherever this expected is used, can you please add the entire logic, whatever statement I have written the right hand side, to this particular statement. So let me just go here refactor. I'll say here inline. You can see we are able to do that. So let me just write few more cases here, and this time maybe I'll pass it as some other string alien, and my expected result would be NEILA. Let's see if we are getting it. So let me run this test. I'll say right click, run as unit test. You can see green bar. That means my test is passing successfully. It is similar to JUnit, whatever we have done previously. And this is how we create JUnit5 test and we run it. We will see more on this in upcoming videos. Now let's understand about this test annotation which we have used over the test method. Now to start with, this test annotation we usually apply over the method to mark method as test. That means this way we are informing the test engine, the platform which we have seen in the JUnit5 architecture, that this is a method wherein we have written our test. This method you need to execute. So here we are just informing by applying this test method out of all methods which method the platform have to execute. And this test annotation which we are able to use is present inside a package called as arg.junit.jupyter.api, and Jupyter API came into picture from JUnit5, JUnit Jupyter, not in JUnit4 or 3. There this annotation was present, however in a different package. Now as I have discussed earlier that JUnit5, which is JUnit Jupyter, is a different architecture altogether. Now whenever you apply this test annotation to a method, that method need not to be public, unlike for JUnit 4 and 3. It could be public, protected and default. Example, you have applied this to a method called as test, and the test method need not to be public, it could be default also. Let's check that by opening the code which we have already written. As you can see, this example JUnit 03, I have tried to use JUnit5, which is JUnit Jupyter, and this method, it was generating the moment I have asked my Eclipse to create a new JUnit test for me. And you can see here, it is not public, it is not protected, it is default. And let me open wherein I have not used JUnit5, I have used JUnit4. Let me open my test. You can see here it is public. When I have asked my Eclipse to create a new JUnit test case for me, it was generating a test method, and we have got here something called as public. That means this test annotated method was public or must be public. However, in JUnit5 you can see here it could be public, it need not to be public. It could be public also, protected also, it could be default also. And by applying this annotation to this method, we are informing the engine that this is where you have to run the test. This is where we have written the test which you need to execute. And let me just run this and show you If I just run this particular test, I'll say here run as JUnit Test, and we are getting green bar. And also let me add this point here. This green bar indicates that the test is successful. However, one point I would like to add here. Usually here in the JUnit, it will test for whether it will test whether it is failed or not. It will check for whatever logic you have written, it is failing or not. It will not check for success. And if it is not failing, by default, it will consider that this is a success. So the default behavior will be success. For an instance, I would not be writing this. Let me just remove this from here. Nothing is there. Still, if I just run this test, let me run this test now. So I would like to run my JUnit test. You can notice we are getting the green bar. It is not checking for the success. Success is the default of this JUnit, the default behavior. It will check for failure. That means within this annotated method, is there anything which is failing? It will just only, it will check only for the failure. And if it is not failing, by default, it will consider that this is success. I hope it is making sense. Now for an instance, this is the method I have applied, maybe alien. Now I'll say here, this is what I'm passing and this is what I'm expecting. Of course, let me run this test again. If I run my test, it should fail. You can notice it is failing. And you can see the detail. It will just, whenever you run the test, it will check for the method with annotation test. Like the way we write main method to inform JVM, what is the start point of our Java application. Whenever we write Java programs, we have to specify main method, and through main method, we are informing the JVM from where it has to begin the execution of Java program. We are specifying the starting point of the execution. Similarly, through this test annotation, we are informing the JUnit engine, which is platform that where the test is present, which the platform needs to run. Now let's talk about assertion, which simply means verification between expected result and the actual result. Expectation versus reality. Suppose I have an expectation that I should be developing a unit or a method wherein if I give this as input, this should be the output. That is my expectation. I should be developing such a method wherein if I pass this as an input, I should be getting the result as this, for which I have developed a unit. After developing a unit, when I run my program and pass a particular data, what this particular unit or a method is giving me as a result, what this method giving me the output, that is the actual output, or you can call it as reality. This was my expectation. I have developed some code, and whatever code I have developed, that is giving me some result. Whatever result that particular code is giving me, that we call it as reality, or you can call it as actual result. Assertion is all about comparing what is your expectation and what is the reality. Let me talk more on this. As you can see here, it's all about expectation versus reality. If expectation is matching with the reality, whatever code we have developed and whatever output it has generated, if it is matching with my expectation, then if you're using the JUnit, you'll be getting the green bar. That means your test is pass. Suppose whatever is your expectation you have given, and then after running a particular code, whatever result it will give you, the actual code, that is the reality. If it is not matching, if you are using the JUnit testing framework, which we have done so far, you'll be getting a red bar that shows that whatever test you have developed, that is failed. And in order to do that, we have used certain methods. AssertEqual, one of the method. Like that, we have so many other methods which are there in the assertion class, which is a part of your JUnit Jupyter API, and all those methods are static method. So let me, like the way we have used assertEqual, and similar to that, assert array equals, assert true, assert false. So many methods are there. We will try to explore more going forward in this entire series. And basically it is present inside a package called as org.junit.jupyter.assertion class. And Jupyter, if Jupyter is coming to picture, I'm talking about JUnit5, or you can say JUnit Jupyter. Of course, if you have to use JUnit4, some methods are present, but they are in the different package because that follows a different architect. And JUnit5, it's all about JUnit Jupyter. We use Jupyter API here. So all the assertion methods, if you want to verify expectation versus reality, actual output, then you may have to use all the methods which are part of assertion class, which is there inside Jupyter API. And after JUnit5, or you can say after it has introduced JUnit Jupyter, it supports all those methods, also supports Java 8 features such as Lambda expression, stream API, which was not there earlier in case of JUnit4. Now we have used one of the method assertEquals in our previous examples. Now going forward, we'll try to explore more methods for the assertion. Write test, then code. Test-driven development methodology, which is one of the pattern or one of the methodology which we follow in order to develop an application. And whenever we follow test-driven development, very often we use JUnit testing framework in order to write our test. Now let's see how do we write test first and then develop an application in this video. So let me just open the Eclipse IDE. And here you can notice I have created one Java project, simple Java project with the name JUnit5, which we have done earlier, and all of you know very well how to create this project. And after which I have created two packages or two folder, source, wherein I'll be writing all my application, all my classes, files, code which is involved for my application development. And I've also created one package or folder which is test, where I'll be writing all my tests for this particular application. So within this source, I have created one package com.telusko.learning, and within this, I have created one class called as shapes. So the application which I want to develop here is maybe which will calculate the area of certain shapes, maybe area of square, area of rectangle, area of circle, such shapes area it should calculate, for which I have to develop some units here. So what I'll do is first let me develop one unit. You may say here first you are writing the code. First we may have to write the test. I'm not writing the entire logic here, just the method signature, because in order to write the test first, some method is required, right? So I can invoke that method wherever I'm writing the test. For that, I'm just writing the method signature without the actual logic. Public, maybe I'll say here double, and maybe I'll say here area of square. I'll say area of, or maybe I'll say here compute or calculate compute square area. And I'll accept some input here. Maybe I'll say here double type the length, double type length. And based on this, I have to return some value. For now, I'll be just telling here return 0. What logic to calculate that, we will develop that later, because first we have to write the test. The test will be failed. Then in order to pass the test, we have to develop the logic. That's the approach we have to follow here. Basic method signature I have developed. Actual logic which is responsible to compute the area of square, I have not written here. In the test driven development, we don't do that. We have to first write the test. So I'll go here. In my test folder or package, I'll be creating one JUnit test case, and let it be JUnit Jupyter, and the package which I want is .telusko.learning, and wherein my class under test is present. Whichever class I would like to test, that is present. So I'll give the name. I have given the name as shapes, and by following the standards, I'll give that as shapes test. I'll say here finish. Please add that to my build path. I've added. Now you can see it is ready. Now as we have seen earlier, we can give the method name, maybe test area. Maybe I'll say here test compute square area method. I want to test this method, so only I have given the name. Choosing the names for methods is quite difficult sometimes, but anyway, I have given this name, and now within this I'll be writing my test. Since the method which I have written here, it's a non-static method. I may have to have the instance of this class, whichever class is under test. I have to create the instance of that class. I'll be creating it. I'll say here shapes type, maybe shape equals to new shapes, the instance that I have instantiated that class. And now using the reference, I would like to invoke that. Before I invoked, directly I'll call the assertion method. And this time also I'm going to use assertEquals. You can see we have lot many options here. assertEqual. So I'll be just using that here. And here I'll be giving the expectation and here the actual which this method would generate. So I'll say here, I'll call that method shapes dot. I think I've given the name shape dot, and I'll compute the area of square, and maybe I'll give it as 24. And if we calculate what should be the expected result, I'll say here 576 should be the expected result. Fine. This value earlier I had calculated 24 into 24, and then it should generate this value. Fine. So this is my expectation. And if I invoke this method, what result it would give me? What would be my actual value which will be generated by this method? Fine. So let me run the test here. I have developed the test first. Of course, it will fail because I have not written any logic there. So let me go and just run my unit case, run JUnit test, and it will fail. You can see here it is failing. Fine. So now I'll be developing that. I'll go back to shapes, and to pass my test, I'll be developing what logic is required. Maybe I'll say here double type result equals to length into length. And if you calculate length into length, that is the result, and this result I would return. Instead of this, you can directly write the program in this style. Maybe you can say here return length into length. Fine. Now it will just take it and it will calculate. Of course, this is very basic application. Just I'm showing the approach. How do we follow the methodology of test driven development here? So I have developed this unit. Now again, I'll run my test. Let me just run this test. I'll say here run JUnit test, and this time it is passing. Now let me have one more unit here. One more unit I would like to develop, and that unit maybe would calculate the area of compute circle area. And for circle you need radius, and the formula is pi r square. So what is the value of pi? I'll say here 3.14 into r square. So I'll say here radius into radius, radius into radius. I have developed, but before we develop, actually in the test driven development, we should not be developing this. So let me just erase this, and I'll just say return 0, return 0. What I have done, I've just given the method signature so that I can call this. What logic is actually involved to compute the area of circle, that I should not be doing it. I have just given the method signature, what I have to do, what I'm going to do it. But what actually the code which is responsible to do that certain task, that I have not specified yet. First, I'll be writing the test. Let me write the test here, and I'll write one more test. So I'll use the annotation test, and within this I'll write void maybe test compute circle area. Done. And within this I'll do one thing. I'll create the instance of this test under class directly at the class level so that I can use for all my cases. And now within this I'll do the assertion assert equals, and within this I'll pass my expected. Before that I'll say shape dot compute circle. So radius, maybe I'll pass the radius as maybe 5, because this value I've already noted down so that I can show you. And if it is pi, the result I should getting is 78.5. This is my expected result. And let me run this particular test case now. If I run this test case, it should fail. As you can notice, it is failing. So first we have to write the test, it should fail, and then we have to develop the logic. Then we have to develop what logic is involved in order to calculate the area of circle. Later I'll be developing. So, and also would like to show you in the assertEquals method, you can also pass the third parameter. If it is failing, whatever message you want that can be displayed, I'll say here, yet maybe I'll say here area of circle calculation is wrong. One message I have given. So let me run this. Of course, I have not yet developed the logic. If I run this, it should fail. Let me just run this and we'll see. Run JUnit test. And if I run, oops, yes, it is failed. You can notice here, failure trace, you can see. Entire trace is also giving. So what was expected? 78.5, and what we have actually got 0.0. Making sense? Area of circle calculation is wrong. That message, whatever we had given here, that is also displaying it. Now let me develop the logic here. I'll go back to my unit and here I'll develop the logic. And now I have actually run the coverage instead of running test. No problem. I'll say here return 3.14 into radius into. That means later I am developing the logic. So I've saved this. Now I'll go back and run my test. Let me just run this test again. Entire, I'm running as a whole. So all the tests which I have written, everything will be running. Now you can see both the test cases are passed, and I'm not getting the message which I had given here. It will be getting only when the test is failed. Now we have seen how to test, how to run the individual test, how to run all the tests which you have written, and how actually what structure we may have to follow. That also we have seen. And with basic application, with basic units, we have also seen how do we approach test driven development. So writing first test then developing does not mean that you're not going to write anything. You may have to at least write the method signature or the unit signature so that you can invoke that when you are writing the test, and it should fail first, and later you have to develop the actual logic. You have to write actual logic which is responsible to give the desired result which you are expecting. And that again, after developing that, again you have to run the test and check if it is passing or not. Now let's create the Maven project and use JUnit5 or JUnit Jupyter in order to create the test. We have done that using simple Java project. However, we will be now creating the Maven project because most of the projects in the industry, we use any of the build tool, Maven or Gradle. So we have done JUnit4 with Maven. Now it's time to create a Maven project for JUnit5. So let me create a new project. Similar the way we have created earlier. I'll say go create others because it's a Maven project, and new Maven project. Next, create simple project, and group ID, I'll give it as com.Telusko, and the artifact ID, I'll say here JUnit5, and it is 06 project for Maven. Let me just finish. You can notice our project is ready. It is a Maven project, and the structure like we have seen before, it is same. All the tests we may have to write within source/test/java, and whatever the classes which are part of our application, those classes we are going to write within source/main/java. Our actual application will be developed here, which we have discussed. Now, in order to proceed ahead, we may have to add the dependency here in the pom.xml file, so that we can use JUnit5 or JUnit Jupyter. So I'll be just showing you what properties or dependencies you may have to add here. And this particular file, I would be sharing you with the GitHub link, or I will attach this entire file. You can also use while you are doing it. So first of all, when you have to add these dependencies, and the version which I'm using here, JUnit Jupyter version, you can notice it is the latest version currently, 5.10.0. This is the latest version for JUnit5. That is what I have used here, and it is JUnit Jupyter and the group ID is, that means package is org.junit.jupyter. Here is where this API is present, and all the methods and the annotations which are part of this API is what we are going to use. So since it is JUnit Jupyter, that means I'm asking my Maven to add JUnit5. Let me add these dependencies first. I would like to add these dependencies. Now I have assigned this version in the property. I would like to add that as well. All these properties. And one more point you can notice here in the properties, I have given Maven compiler.source 14. That means I want to use Java 14 here, because whenever we create a Maven project, by default it will take Java 1.5. That is a default behavior. However, JUnit5 will support 8 version or higher than 8, maybe 11, 14, 17, but not lower than 8. So I have to add whichever version of Java you want. You can give 1.8, 11, 14. It's up to you. And the latest version of Maven is what I have added here. And let me just add the certain more plugins here. This plugins also would like to add, and this file anyway I'll attach. You need not to worry. You need not to work much on this. Now you can see Maven compiler plugin, which is required to compile this entire Maven project. We have many more plugins we will see. We have a surefire which can be used to run the test cases using filters, and we can use for the reports to generating the reports. So many things we will see that in the upcoming entire series. However, these dependencies have been added. Let me save this. After saving, you can notice now it's still 1.5, but I need 1.8 or higher. So what I'll do is I'll go to my project, right click, and you can see here there is an option of Maven, and then update project. I'll click on update project, and I'll say here okay. Now you can see Java 1.14 has been added. So let me save this now. All the required dependencies have been added. Now, as we have discussed earlier also, we may have to create the test within source/test/java. Within this, I'll be creating a new test. I'll say a new JUnit test case. If not, you can create your own class, and within that class, you can just write a method which is responsible, write a test with annotation. That method must be annotated with the annotation test. So let me create using the Eclipse ID itself. And the package, maybe I'll give it as com.learning. Maybe I'll say here com.Telusko.learning. And the name, I'll give it as test trial. I'll say here finish. Yeah, your package, as we have discussed, you have to give for whichever class under test. Wherever the class is present, the package must be same. It is new JUnit Jupyter test. That means JUnit5. So let me just finish. And you can notice here our test is ready. I don't want to explicitly fail it. If you want to explicitly fail, you have to use this fail method. I want to use the assertEquals, which we have used earlier, and just for the demo purpose. Now within this, maybe I'm expecting the result to be 6, and I'll say here what is the actual result which my unit may generate. Maybe I'll say here 3 plus 3, something, some activity, or maybe I'll give it as here also 6, doesn't matter. So this is the expected, and this is the this is the actual result, and this is the expectations, and both of them are matching. So of course the test must run. So let me run the test here. Right click. I'll say here run as JUnit Test. You can notice our test is running successfully. Green bar, that means test is passed. And this is how we may have to create it. And if you want to add all the projects, as we have discussed in JUnit4 Maven project structure, example, I want to test this. So let me just add this entire thing. And if it is in the Maven, you have to add in source/main/java. Here is where we have to develop actual applications. I have taken the application which we have developed in the previous example, wherein it is calculating the area of shapes. Let's try to write a test for these units. So let me go here and just let it be there. If you want to write one more test, I would like to create a method called as void and void test. Maybe I'll say here compute, which method we want, which unit, compute square square area. This is the method I want to compute. And as you can notice here, whenever we are using JUnit5, it is giving us default methods, because JUnit4 it has to be public. All the methods which you are annotating with the test has to be public, but from JUnit5 it need not to be public. It could be public, there is no problem. It could be default also. Now, unless and until I use one annotation test, it will not be considered. Now test, that means JUnit engine will consider this also in order to run. Now here, what I'll do here is I'll say here assert equals, and let me see my expectation. What is your expectation? I'll say here maybe 576, and I'll call this method. For this, instance is needed. So first I'll create the instance of shapes. I'll say here shapes type shape equals to new shapes, because it is a non-static method. And using the instance, I'll call that method. I'll say here shape dot and compute square area. And here I'll pass 24. Now 24 square means length into length. 24 into 24 will give you 576. Let's run this particular test and see if it is working. Right click. I'll say run as JUnit test. Run as JUnit test. You can notice test is passing. Now let me give some other result here, and this is my expectation, and this method or unit would generate a different result. Let me check and run this particular test which I have written, and you can notice test is failed. So with this, we have been able to use JUnit5, JUnit Jupyter, both in normal Java project or in the Maven project. Depends on your need. From upcoming series and lectures, you can use either Maven, you can create either Maven project or Java project based on your need. As we have seen so far, if you would like to run the test which we have written here, we just have to right click and run as. Directly we have an option as JUnit test, and we could able to easily run the test with just some clicks. And this is happening because of Eclipse. Eclipse IDE internally integrated with the test runners of JUnit framework, for which we need not to do something explicitly here, and easily we could able to run the test as a unit, or maybe whole test, how many cases you have written, all of that at once if you want to just. And there also we have an option, run as JUnit test. Easily we could able to run all the tests which we have written here. What if I want to run the test without having to use the facility which Eclipse is giving to us? In Eclipse it is easy. Right click, run as JUnit test, and this facility is from the Eclipse, and I want to do that independent of Eclipse. What if maybe my project is going in CI/CD, there build process is not going to install the Eclipse and right click and run as JUnit test case. In that case, I want to run as a whole project, maybe by using the facility of Maven test, for which we may have to integrate one of the important plugin, which is surefire plugin. How to do that integration is what we are going to see here, and most of the projects and most of the companies will be looking for it. So I just have to add one of the plugin. And as we have seen within the build, after the dependencies, I have already added one plugin, and here I just have to attach surefire plugin. So let me just attach that here, and this entire file I would be sharing with you. So let me just add this particular plugin, and as you can see, I'm able to add this surefire plugin. Now what I can do is, I will not need it to use the facility. If you are comfortable with the Eclipse, maybe right click, run the JUnit test. There is no problem, no harm. And I'll have now one more option. If I just click on my Maven project, right click, and you can see run as, I have an option of Maven test. I'll just click here test. And as you can notice on the console, so many options I'm getting for the first time. You can see here, and you can just scroll down and maybe let's see all the required things for the first time. It is just installing, and now you can see test. Every time all these things will not come. For the first time when you are integrating this surefire plugin, you'll be getting this, and now you can see I could able to run the test here. I'm not getting that green bar or red bar, which was the facility which is given to us from the Eclipse IDE. I'm able to run this as an independent without having to use that. And you can see here, there are two test cases, 0 failures, and what is the result? 0 failures, 0 errors, 0 skipped, and both of them are success, build success. And this is how we could able to perform Maven test or project test without having to use the facility of Eclipse IDE, and for which we just have to attach this important plugin here. Maybe let's change the version of this surefire plugin, which could be the latest one being 3.2.1, and let me just see if could able to run this. And I'll just go here. I'll say here run as Maven test, and if you're not getting this, you can go to the Maven build. There you can mention the goal as test and you can run it. So let me run Maven test. Again, since I have changed the version and all the required files, it is just installing, it is downloading, and you could be able to see now we will be in a position to run the test without having to use the facility of Eclipse. See, test, and as you can see, build success. That means both of our test cases, which is a part of our test, are success, 0 failures. And this is how we could able to integrate surefire and able to run our test without having to use the facility of Eclipse IDE. Now let's understand more on assertEquals method. As you have seen so far, in all the test cases we have written, we have used assertEquals method. And very often we have passed two arguments here, two parameters. Number one happens to be the expectation, and second, the reality, what that particular unit would actually generate. And also in the previous example where we have seen, we had passed one more argument here, which is a string type message, and that would be executed only if, or that would be displayed only if your test case is failing. That means if expectation is not matching with the reality and your test case fail, and whatever string message you are giving here, that would be displayed. For an instance, I would like to run this test here. Right click, run as JUnit Test, and if I just run this test, you can notice it is passing and we are not getting any message. Now maybe I'll give my expectation is 76.8, and this method would generate me something else, that is actual result. And now definitely expectations and reality will not match and the test case has to fail. I'll just right click, run the unit test, and you can notice red bar. And also one more important point, whatever string message you had given, that is getting displayed here. Same thing I can do using one more approach here. What is that approach if you ask me? By implementing supplier interface. Instead of directly giving the string value, I would give the same message, but by implementing supplier functional interface, which is Java's functional interface, and by implementing that, you can do that. And what will be the difference if you do so, and how do we do that, we will understand here. And let me just reuse the same test case and I'll just change it here. I'll give here a circle. Maybe I'm going to implement now supplier, and now supplier is a functional interface. If you want, you can implement in your own way, but since it is a functional interface, I would implement using the lambda expression. So parameters required, and then I'll use the lambda operator and the actual implementation. So this time I'm giving the message here using the implementation of supplier interface. Direct string message I am not giving here. So now let me first pass the test here, and I would like to run this particular test which I have written. So we are getting the result, no problem. Well, now I would like to fail this test. Maybe I'll say here 74.5, and this would give me something different, and the actual and expectations will not match. And you can see, right click, run unit test, and if I run, we are getting this. Let me just rerun, and I should be getting the message as well. So I'll run JUnit test case, and see, you can notice we are getting the message, whatever message we had given here. So what is the difference? Both the methods are behaving same. What is the difference between this and this? Here you're directly passing the string message, and if you pass the string message directly, this assertEquals method is evaluating that. Evaluation is happening, that string message is being considered, and by chance if test is failing, it is displaying that message. If test is passing, that message is not being displayed, but that message, the string object, is getting evaluated. In this case, whatever you have given using the implementation of the supplier interface, it will be executed only if the test case is failing. What do we mean by that? By chance, if the expectations and reality, if both of them are matching, that means test case is passed. And if test case is passing, this part will not even be evaluated by assertEquals method. That will not be considered. And only if the test case is failing, expectations and the reality is not matching, only then the evaluation is happening, and whatever message you have given here in the form of string, that is getting displayed. So the only difference here is this is the efficient way of writing or giving the message to developer just in case if the test case is failing. And here also you can do it, there is no problem, but that will be considered only if it is failing. The display, assertEquals method is displaying that. If it is not failing, if the test case is passed, display of that message is not happening, but that has been considered, that has been evaluated. Here evaluation only will not happen if the test case is passing. If the expectations and the reality is matching, evaluation only will not occur. Only if it fails, it will evaluate, and whatever message you have given, that will be displayed there. So implementing the supplier functional interface and giving the message would be more efficient. Now let's understand one more important method in order to perform the assertion, which happens to be assertEquals. By the method, its name itself, you can understand it is to perform the assertions over the arrays. And if you want to pass the test case by using assertEquals method, then actual array which is generated by a unit and the expected array, it should match. If both of them are matching, then it will result in test case pass. And in order to match that, you have to make sure that the number of elements which are there in both the arrays should be equal. It should be same number. If one array is having 5 elements, the second array, it should also have 5 elements. Not just that, it should also have the same data. Example, the first array has 2, 4, 5, and the second array should also have 2, 4, 5 only. The data also it will check. The elements which are part of that array also will be checked here. Apart from that, the order of those elements has to be same. If all of these requirements are matching, only then the test case would pass. If not, the test case would result in fail. Now let us check that practically in order to get a better clarity. Here you can see I have developed one unit wherein I am going to test my array. So what I'll do here is I'll have one array here by the name, maybe this is my expected array, and here I am going to pass some data. Maybe I have some even numbers here, 2, 4, 6, 8. Fine, this is one of my array. And one more array I'll have, integer type, maybe this is the actual array which I'm getting from a unit. And now here I would be writing in this style, 4, 8, 6, 2. Fine. Now both of them have same number of elements, 4 and 4, correct? And both of them have a same elements. Here also we have a 4, here also we have 4, 8, 8, 6, 6, and 2 and 2, but order they are in is not same. So let us check here. I'm going to use one method called as assertEquals in order to perform the assertions, and I'm going to pass here the expectation, what is the expected and what is the actual that my unit is generating. Now you can see here it should fail. Let me check if I have to run this. See here, it is failing. If you open here, you can get here where exactly what is happening. You can also cross check. You can see array content differ at index 0. In the index 0 itself, I was expecting 2, but I found 4. And this was my expectation, but I could not able to find that exact message. Also JUnit is able to display to you what exactly the problem with respect to this test. Now I'll do one thing here. I'm going to perform some of the operations over my actual array. I'll say here arrays dot sort. Arrays is a class, utility class, in order to perform the operations. So let me give here arrays dot sort method, arrays dot sort, and within this, of course, I may have to import that. And here I'm going to pass actual array. If you sort this particular array, then it will become 2, 4, 6, 8. And after I sort it, of course, the return type of sort method is void. You cannot print and check it, but it will sort the array. And this array, if you sort, then it should result in 2, 4, 6, 8. And now tell me, both the arrays, number of elements are same? Yes. The expected array and the actual array, both of them have same number of elements. And the order of the element and the elements, both of them are same. It is also 2, 2, 4, 4, 6, 6, 8 and 8. Order and what is the element? All of that is satisfying here. All three conditions are satisfying. In that case, this particular test case should pass. Let me just run this test case and see. And you can see test case is passing because both of them are matching here. Now in place of assert array equals, if I use the normal assert equals method, and I'll pass here what is my expected, and I would also pass here the actual. Now let me just import it, and if I have to just run it, all right, now I would like to run this, right click and run as JUnit Test. And if I run, you can notice it is failing. Why? Because it will check the reference variables. If you just know the basics of Java, on your heap memory, we will have two array objects. One array object is referred by expected and one more array object will be there which is referred by actual. Now both of these reference variable are referring to two different arrays. So it is checking the reference variable. It is not checking the data which is there inside those arrays. And if you want to perform the assertions or verification with respect to the elements which are there inside the array, then you should not use assert equals method. You have to use assert array equals, and assert array equals will check for the data which is part of the array. That means what data, whether it is in the proper order and the elements, the data is same or not. All that it will check and then it will result. Now both of them having the same alongside the order, elements are also same, order of the elements also same, and number of elements also same. It is not just with respect to the integer array. You can perform with respect to the character array or string type of array. Now array could be of any type. The type of the data should not be a concern here. Type of data not a concern. I'm referring to both of that should be same. Example, if I have an array which is having a string array and one more array is integer array, then the type is different here. The elements are different here. In that case, it will fail. So suppose both of them are string array and now both of the array have same number of elements, same type of element and same element also alongside the order of the element. If that is the case, then the test case would pass. If not, the test case would fail. And this is how we can use assert array equals method in order to perform assertions over the arrays. Now let's understand about asserting with exceptions. That means testing the exceptions, whether a particular unit is generating the exceptions or not. For an instance, here in this class, I have developed a unit or a method which is responsible to receive an array and sort that array and return that sorted array to the caller of the method. So whenever you want to sort any array, you can invoke this method and you can pass this array, and this method would accept that array, perform the sorting, and after sorting the sorted array, it will return back to the caller. So here, if you are passing an array which has some data, it will take and it will sort. Of course, it is an integer type of data. But however, if you pass an array which has null, no data, maybe an array with a null reference, and that array if you pass here, this particular unit would generate a null pointer exception. We will try to execute this and check whether this unit is generating an exception or not. So here I have developed a method or a test case, and here what I'll do is I'll be invoking that method. In order to invoke this method, first I need the instance of a class where my unit or a method is present. So I'll go here and create the instance of a class, type maybe array equals to new, and the instance is ready. I'll say here array dot. You can see here we have a method sorted array, and here we have to pass an array. So I'll be creating one array here, integer type unsorted array. One unsorted array I would be creating. And if I pass some data, there is no problem. And this I'll be passing here. Maybe I'll give it as unsorted. The reference I'll pass here. And this method would accept this array, perform the sorting, and then it will return back the array to me. So I can collect it back after I pass the array. I can collect it back, and I'll say here maybe integer type. I'll say here sorted array. Integer type sorted array. And now you can iterate over it using the loop, and you can check for. And I'll say here integer type maybe element of an array. And what is the name of an array? Sorted array. This is an enhanced loop to iterate over the array and to fetch the values. Now I would like to print system.out.println, and I would like to print whatever data I have inside that array. So let me just run this and let me see if I'm getting the result first of all. So here 1, 2, 3. So it was not sorted earlier, 2, 1, 4. Now after invoking that method, this method is able to sort, and I'm getting the result 1, 2, 4. Now I'll not be passing here an array, rather I'll make it null. That means here whatever array I'm passing, that array does not have any elements. It is a null with a null reference, nothing is there. And now I'm asking this particular method to take this and try to sort. It cannot sort because there is no data in whatever array it is receiving. We have only null value, and it cannot perform the sorting. Hence, this particular unit would generate an exception, and that exception will be coming here. So what I'll do here is, for now, I'll just comment this, and I'll be handling within a try and catch. Very simple. First step, I'll say here try, and then I will say here catch. And you know very well, in Java, catch block will get executed only if there is an exception. So I'll catch here null pointer exception type maybe E. And within this one message, I would like to give system.out.println. I will say here exception generated. Now, if we are getting the result, whatever is present inside the catch block, that means that particular unit is generating an exception object. And we know very well, in Java, catch block will get executed only if there is an exception object. And if exception is not generated, whatever you write inside the catch block, that will not get executed. Now let me run this here. If I have to run this particular unit, run as JUnit, and you can see exception generated. So this exception generated message is present inside the catch block, and catch block will get executed only if there is an exception. That means whichever method we are invoking, that method is generating an exception, and test case is passed here. Now, you know very well that the line where exception occurs, lines below that till the catch block will not get executed by chance if there is any exception here. What do you mean by that? Maybe in the line number 16, you are invoking array.sorting array. And if this particular method is generating an exception, whatever statements you write here, those statements would not be executed. Maybe here, I'll say here statements below exception. It will not get executed by chance if there is an exception here. So let me run this here. I'll say here, run it. See, I'm not getting that message. Now, however, I would like to pass this. That means maybe I would like to pass some data here. I'll say here 2, 4, 5. Now, if I'm passing here, there is no exception. Whatever message you have given inside the catch block, that will not be executed. And this line also will be executed. This line also will be part of our execution, because everything apart from the catch block will get executed if there is no exception. Now, I'm invoking the method and passing the proper data here. That method can accept it and sort and give you back the array, the sorted array which you are collecting here. So there is no problem here. So let me just run here. Right click, I'll say here run unit. You can see here statements below exception also we are getting it. Since I'm not iterating, so I did not get that. However, we are getting this. So let me just iterate over and show you. I would like to run this particular test case once again. We are getting the sorted array Also then we are getting statements below exception, but the test case is passing here. I want to fail this test case by chance if there is no exception. Now, right now exception is not generated. What do you mean by that? Exception is not generated because whatever message we had given inside the catch block is not executing. If catch block is not executing, that means there is no exception. And if exception is not generated, test case should fail. And if exception is generating, the test case should pass. So what I'll do here is, after this statement, I'm going to fail explicitly. This will be probably the only place wherein you are failing the test case explicitly. Now, my dear friends, please see very carefully. If this method which I am invoking, if it is generating exception, lines below this would not be executed until the catch block. If exception is generating here, directly it is the catch block which gets executed. It is a concept of Java, and lines below this will not get executed. And if it is not executing, that means test case is pass, because the explicit failing I am doing before the catch block, after the exception generating statement. So these statements should not be executing. If it is not executing, fail also would not get executed, and test case will not fail, and test case will pass. Now, if exception is generating, now I would like to generate the exception. Null I am passing. So if I invoke this method and pass null here, that method will throw an exception, and exception would be generated at this statement. If exception is generated at this statement, all this will not get executed. Directly it is the catch block. So let me run here. If I just have to run this, test case is passed, exception also generated. By chance, if exception is not generating, the test case should fail. So if I have to give here maybe a null value, maybe some array I'll give. If you pass a normal array, then in that case, test case exception would not be generated. If exception is not generating, I have to fail the test. So explicitly I'm failing. Catch block will not execute it. All other statements will be executed. So let me just run this, right click. I'll say here run unit test, and you can notice I'm getting the fail. That means I'm failing the test because there is no exception. So basically here, test case should pass if there is an exception, and test case should fail if there is no exception. Now test case is failing. Why? Because there is no exception. Whatever unit I have developed that is doing task, it is not generating any exception. If it is not generating exception, test case should fail, and I am failing this. This is one of the way, and there is other way also if you don't want to use this. So what I'll do is I'll comment all of these lines, all these statements I would like to comment. And now I have created the instance, and there is a new method in the new API, assertThrows, and you can see here it is accepting the type of exception and implementation for executable. Both it is expecting. So assertThrow, and I'm expecting null pointer exception. Null pointer exception I'm expecting. So reference I'll give it as E. I'll say here maybe dot class. I have to give the reference with the dot class. So dot class. And now I'm going to invoke that method here. What is the reference variable? Array dot. And the method name is sorting array. And whatever the statement is there, I would like to give here. Right. So I'm going to pass here unsorted array. And this you have to do by implementing the executable. That means you have to implement using the lambda expression, the easiest implementation. I'm implementing lambdas. By implementing the lambdas, I'm invoking this method. Now, if this method is generating null pointer exception, then the test case is passing. If this method which I'm invoking, if this unit is not generating null pointer exception, this would fail. Right now, I'm passing the proper data. And if you are passing the proper data, then this method which I'm invoking, it would not generate any exception. And whatever test case we have, that should fail. So let me just run this. And you can notice it is failing. Why? Because it is not generating. I'm not giving null here. I'm giving a proper array. And this method, if you give proper array, it will take that, it will sort and give you the sorted array. So of course, it will not generate any exception. Now what I would do is, I'll give here as null. So whatever array I'm going to pass here, you can notice that does not have any data, any element. It is with a null reference. So of course, this method would generate an exception called as null pointer exception. Now, if it is generating null pointer exception, whatever exception I've specified here, that means my expectation is matching with the reality. And if it is generating, my test case should pass. So let me run my test case here. And you can see the test case is pass. That means that particular unit is generating exception. And this way, without using assertThrows also, we have seen how do we test exception by asserting through the method assertThrows. Also we have seen how do we check whether a particular unit is generating exceptions or not. Now let's understand about testing the performance of a unit. Whenever we have a longer running task or longer running unit, maybe a unit wherein we have a lot many tasks and it might take a lot of time in order to perform, we may have to test the performance of that particular unit. And how do? We have to understand here. For an instance, I have a unit which is developed in front of you. You can see here. And here I'm trying to sort an array, and arrays.sort method, you can notice here I have kept inside a loop, and I want this to loop for maybe 10 lakh times. That means this sort method would be called for 10 lakh times. Now again, somewhat I can say here, it might have a longer running task and I want to check the performance of a unit. And if you want to do so, how we have to do? Now please see here, I have developed one test. I have written one test here, and wherein I have created the instance of the class under test. And whatever array I would like to sort, that array I have created here. Now, in order to test the performance of that unit, I can use one method if you are using JUnit5, which happens to be assertTimeout. And if I just check here, assertTimeout, you can see we have a assertTimeout static method, and it is an overloaded method. And however, you can notice here, it is expecting me to pass the duration. You'll understand. And also it is expecting me to pass the implementation of executable or implementation of the supplier. You can see here, two things I have to pass here. Number one, I can say here, how do you check? Maybe I'll say duration dot in milli. See, duration of milli. And I'll say here maybe whatever unit I am testing, that has to execute within 10 milliseconds. That means 10 lakh times invoking the sort method should be finished within 10 milliseconds. If it is not able to do that, my test case would fail. And if it is able to finish calling the invoking the sort method for 1 million times, or you can say 10 lakh times, then my test case would pass. Now I want to check the performance that whatever unit I am going to test here, that has to be completed within 10 milliseconds. Now, let me give the implementation here with respect to the implementation of, usually we do the implementation of functional interface using the lambda expression. That is what we have seen here. I hope you know that much of Java. So I'm going to implement, now I will say here, array dot, that method I would like to invoke, array dot, and you can see here, sorting array, and I'm going to pass here unsorted array. Now it will accept this, and that unit is executing the sort method for 10 lakh times. Now I would like to just run this particular test case and check if my method or unit is performing well. You can notice test case is failing. Wow. Now I'll do one thing here. Maybe I'll give little more time and I'll check here with respect to maybe 100 milliseconds, and let's test. I'll right click. I'll say here run unit test. Test case is passed now. That means whatever unit I had developed, it is able to execute within 100 milliseconds. And if I check with respect to the 10 milliseconds, that unit is not able to execute and the test case would fail. So let me just execute this unit. In this case, I want that unit to execute within 10 milliseconds. Oh, it is happening. Let me give the time as 1 millisecond now. I'll right click and I would like to run. It is a red bar now. That means my test case is failing, and it says that you cannot, you can consider that this particular unit cannot complete the task within 1 millisecond. So with this method, assert timeout method, we can check the performance of a particular unit, and you can see off millis, off minutes. You can give any method here. Let me just show you once again. I'll say here duration. You can see dot. You have all the options. I have gone with respect to millis. You can go with nanos, minutes, and now I have checked with respect to 10 milliseconds. And this method would able to execute and able to call the sort method of arrays, class for 10 lakh times within 10 milliseconds. And if it is happening, the test case would pass, and you can notice here. And this is how we can use assert timeout method in order to test the performance of a unit. However, if you are using JUnit4, we do not have this option. You may have to, within the annotation, you may have to specify timeout directly here, and you may have to give maybe 100 milliseconds. Now it is not working here because I'm using Jupyter API. This option is not available for the JUnit5, and it is there maybe whatever projects we have created earlier with JUnit5. Let me open that. And here with this annotation, I'm going to check whatever unit I'm going to execute, whether that is executing within the time frame. So I'll give here timeout attribute, and I'm going to say here maybe 100 milliseconds equals to 100 milliseconds. Now see, it is working fine. So let me run this test. I'll say a right click, run unit test, and you can notice the test case is passing. So if you are using JUnit4, you can just specify in the annotation test timeout, and if you are using the latest JUnit5, you may have to use assert timeout method in order to test the performance of a unit. You must be knowing the typical life cycle of a normal Java class. Whenever we have a class, if there is any static initialization block, that will get executed first. And then if we have any static method using the class name, you can invoke that would be executed next. And then we will be creating the instance of a class, object creation. And during the object creation, the constructor would be invoked. And after constructor, and if we have any non-static method, that means instance method, using the reference of the object or an instance, you'll be invoking that instance method, non-static method. And that is how the execution will happen. At the end, the object would be destroyed, and that is how a normal Java test class, a normal class of a Java would be executed. Now, what is the case with respect to the class wherein you are writing the test cases? What would happen there? What will be executed first? What will be executed next in that case? We need to understand here. In other words, we will be understanding this by understanding important annotations we have here, which is before each and after each, for which you can see one application I have and 2 units we have here, and we will write the test cases for these units and understand those annotations. Now you can see I have written one test case here, and to invoke these method, first I have to create the instance of the class under test, because that is a non-static method which I am going to test here. Same thing goes here. So basically I have written 2 test cases. Fine. Now what happens here is, in order to invoke this method, of course, whichever method is annotated with test internally, test runner would be executing that, and this is a non-static method. So in order to invoke these methods internally, you need to create the object of this test before after, whatever class wherein you are writing the test. So internally, testing framework JUnit will take care of that. So first what will happen, it will create the object or instance of a class wherein you are writing the test. And when you're creating the object, that means constructor is getting called. So it is constructor first. And then using the reference, you are invoking internally the methods which are annotated with test, that would get invoked, and that will be executed here. Now maybe I want to execute some of the code, some task which is common for all the test cases I am writing here. So what do we mean by that? in this context, creation of this object I'm doing in order to invoke these methods. Here also I'm doing the same because this is the non-static method. You have to do that. By chance, if you're writing one more test case, if you're invoking any of the method of the same class, then again you have to create the instance. That means duplication of case is happening, duplication of the code here. So what to do here is I'll be creating one method, normal method. Please understand this. Maybe I'll give the name as init method. You can give some other name, no problem. I have given it as init method. And here I'll be creating the object. Before that, I'll create one instance variable, shapes type shape, and within this init method, I would be creating object or instance of the class under test, and to this I'll be creating reference by the name shape. Fine. And just to demonstrate and see the control flow, I'd be writing one sysout system.out.println. Maybe I'll give the name as before test. Fine. Now to this method, I'll be annotating with one annotation called as BeforeEach, and I'll be importing that. So it is being imported. Now I'm able to apply. But the name of the annotation you can understand, BeforeEach. That means before each test, this would be executed. So if I have 5 test cases, before running 5 test cases, this would be executed. That means init method would be called internally by the framework for 5 times because you have written 5 test cases. Right now I have 2 tests. So how many times init method would be executed? 2 times. So now anyway, I have already created the object here. So I need not to write this again. This duplication is not required because even before executing this particular test, it will internally first call the method which is annotated with BeforeEach. Then it will call the method with annotated with the test annotation. And again, before executing this, first it will execute init and then again whatever you will be writing here. So let me just also write one thing here, system.out.println. Maybe I'll say here actual test running. And same thing do here just to see the console on the console control flow. And now I have saved this and I would like to just run my test case. So let me run it. Ignore whatever we have seen there. Now you can see before test, actual test running. Before test, actual test running. That means before every test, this init method is getting called. It is not init method. Any method name you can give. There is no problem. But whichever method is annotated with BeforeEach. BeforeEach annotation, it is there in Jupyter, JUnit5. If you're going with the JUnit4, then you just have to use before, just before. You should not write, each, only before. It will work for the, JUnit4, and now in JUnit5, it is enhanced. So of course, it is giving the precise name. But the name itself, you can understand. This particular method has to get executed before every test. Usually we do whenever we have to initialize any instance variable or maybe some DB connections or any activity which is common for all the test cases, because this would get executed before every test. If we have 10 test cases, 10 times the init method would be invoked. So if something is common for all the 10 test cases, you need not to write that inside those tests 10 times duplication of the same thing again. Instead, you can just write within this method which you can annotate with BeforeEach. So if we have BeforeEach, we have AfterEach, and now I guess you can, get to know what is AfterEach. So I'll write one method called as destroy, and here I would be writing just to see the control flow after test, and this method I'll be annotating, and you can understand the annotation by the name itself, after each. So let me import this. I have imported, and it is coming from the Jupyter API, that is JUnit5, and you can understand, I think by this you have already sensed, after every test case this would be executed. And usually we do this whenever we have a cleanup or closing of the resources. Maybe some of the resources you are using inside this test cases, and after executing that, after running that particular test, you want to close the resource, which is common, and that part you can write within a method which you can annotate with after each. So if you are aware of exception handling, try catch finally, usually whatever the cleanup, closing of the resources or cleanup code we usually write within the finally block, something similar here. So whichever method we annotate with after each, that will get executed after every test case. So let me run here. I would like to execute this particular unit case, and you can see here, run this, and you can see, let me just show you the console. Before test, actually test running, after test clean, after test, that means cleanup is happening. Before test, whatever test you have written, that is running after. That means whichever method you annotate with before each, that method would get executed after, before every test case you are writing. If you have 50 test cases, that method which you're annotating with before each, that will get executed 50 times. And same goes with respect to after each. After every test, that part would be executed, usually to close the resources. Maybe we are doing some DB related activity, or we are working with the files, and once the test is over, we want to close those resources, and that we can do here, because anyway this method will get executed after every test case. And if you're going with the JUnit4, similarly, you need not to use each, you just have to use after, and that will get executed after every test case. In JUnit5, they have just given the precise names: before each, after each. So what is the life cycle here? So object or instance of this class is getting executed. That means constructor is getting called. And after that, before invoking the actual test, it is invoking a method with before each annotation. And then it is invoking destroy after every test case. We'll understand more in upcoming video. Now let's understand about the annotation before all and after all. What will happen if we apply to these methods? So you can see here, before each, after each, we have seen that will get executed before every test case. Now I would be writing one method here, and maybe I'll give the method name as void before all. And this is a method name I have given. Whatever name you want, you can give. Here also it need not to be init, it could be anything. But this method now I'm going to annotate with the annotation called as before all. And one more point here, you are able to apply, but if you run, you may get exception at the runtime. So you have to apply this annotation for a static method. Usually we use this annotation for a static method. So I'll make this method as static. And if it is a static method, that means it is independent of the instance. It is not dependent on the object. Without the object, with the class name itself, you can invoke that. Keep that in mind. And also I would like to print one message just to trace the control, what is happening, which is getting executed first. I'll say here before all tests. Fine. So now if I just have to run this particular test, I'll say here run my test, and you can notice the output before all test. So before test, which is present within before each annotated method, is executing before every test case, wherein before all tests, you can see it is getting executed only once. That means before all the tests, only once this will be executed. And this usually we have to apply to a static method. Static method means you need not to create the instance of a class to invoke this. So what is happening with respect to the test cycle here, the life cycle, if you see, before even creating the object of a class wherein you are writing the test case, that means before the constructor execution, it is this method which is getting called. So this is the first method which is getting called here. Then the object is getting created, that means constructor is getting created, and then before each test case, if you are writing a method with before each annotation, that will get executed. If you are not writing here, it will be just this test case which you are writing. So basically, if something is common for all my test cases, maybe all the test cases I'm testing some of the methods or units which is doing some DB related activity, that means database related activity from your Java application, and establishing the connection to the database is common for all these methods, which I can specify in a method, in a static method, which I am annotating with BeforeAll, because this method would get executed, would get called only once before executing all the test cases. If you have 100 test cases, will this method be invoked 100 times? No, it is only one time. And this is the method which is getting called first, even before the instance of this class is getting created internally. So even before this, it's a method which is annotated with BeforeAll is getting invoked. So that also you have to keep in mind. Maybe if something common is there for all the test cases which you are writing and which you want to execute only once before even you run the test cases, then you can write a static method with annotation BeforeAll. So if we have BeforeAll, that means annotation which is after all, and I'll give here as after all, and the method name, whatever you want, you can give. I'll give the method name as after all. I'll say here after all the test, and this also would be invoked only once after all the test cases are running or executing. So let me just run this particular test, right click, I'll say here run my unit test, and you can notice all test, it is coming only once. Whatever message you have given here, it is coming only once. That means it is getting invoked only once after all the test cases are executed. So this also you may have to apply to a static method itself. Fine. Make sure that these methods are independent of object, independent of instance. And it is doing exactly what before class and after class annotation used to do in JUnit4. So whatever is happening here, just in case if you are unaware of JUnit4, we had an annotation called as before class, after class. Same thing is happening here with the annotation BeforeAll. They have just given the precise name before all test cases, and this will be executed only once. Before each test case, 100 test cases you have, whichever method you are annotating with BeforeEach, that will be invoked 100 times. But whichever method you are annotating with BeforeAll, that will get executed only once before executing all the test case. And whenever you want to close the resources, a common resources you want to close, and in that case you have to use after all annotation to a method, and at the end of everything, if all the test cases are executed, that time it will be invoked. And I cannot show you the same example which we have done here by creating the object. I cannot create the instance here because static method, it is independent of instance. So you cannot have something about instance here, because this method would be called even before creation of the instance, even before creation of the object. Fine. Now one more thing you need to understand here. Now these methods wherein I am writing my actual test, the method which is annotated with the test annotation, here is where the test we are writing. Now suppose I am writing two tests here, and if it has to be invoked internally, the platform, the test runners would create the instance of this class, and using the reference it would be invoked. And also I would like to tell you that default behavior in which it is working is how much ever test cases we have, that many instances would be created. That means in order to invoke this test case, first it will create an instance of test BeforeAll, after all, this class. And then it will invoke this test case. And again, in order to invoke this, one more object would be created. So if I have 5, test cases I have written with a method with test annotation, then 5 times the object of a class wherein you are writing this test case would be created. What do we mean by that? So let me just execute the constructor. That means whenever we create an instance or create an object, constructor would be invoked. Just to demonstrate this, I would be creating one constructor here. And within this constructor, I would be giving one message, system.out.println, maybe one message I'll say that test object, maybe I'll say a text object is created before test method. Fine. So let me just run this. I'll right click. I'll say run as unit test. So one thing you can notice here, test object is created before test method. Test object is created before test method. That means this message is getting displayed 2 times, and this message was present within a constructor, and constructor gets called whenever we create the instance. So right now I had two tests which I have written here. So in order to invoke those methods, two times the object is created. So 5 test cases if you have written here, that means 5 methods with annotated with the test annotation, then 5 objects of an instance would be created. And I don't want that to happen. I want it to create only once, the instance of a class only once, and then using the same reference, I want it to invoke all these methods which are part of this particular class. If that is the case, then we have to use one annotation in order to change the behavior of test instance. So the annotation which I have to use here is test instance. So annotation is test instance. And this annotation, let me just import it. And this is coming from the Jupyter API. That means it is there with the JUnit5. And here one enum I have to pass. I'll say here test instance dot, I'll say here life cycle dot, and you can see per class per method. So per method, if you say this is a default behavior, so even if you don't say this, the default behavior of this class is per method. That means for every test method, the instance is getting created. So if we have 100 test methods, 100 times the instance of this class would be created. And I don't want that to happen. So in place of per method, you may have to go with dot per class. Now, if this is the case, the instance would be created only once. And also, whenever you're creating the instance only once, multiple instances are not creating. So there is no meaning of having a static method. Static method usually we write whenever we have a common activity which has to be executed independent of the object. So we used to write here BeforeAll to a static method, so that doesn't matter how many test cases we have and how many objects internally the test runner would be creating. In order to invoke this, it will be executed only once. So right now I have changed the behavior, right? I have just told here that please create only one instance. So only one time the instances are getting created. And if you are changing the behavior here, in that case, you need not to write the static method. You can apply BeforeAll to a non-static methods also, because there is no meaning at the end of the day, because anyway we have only one instance, one time only this method would be invoked. So if the behavior is per method, you have to apply BeforeAll after all to a static method only. But however, if the behavior is per class, and if you're changing the behavior, only one instance will be created, and using the reference, all these methods would be called here. And in that case, this BeforeAll and after all, you can apply to a non-static method also. And let me just run this and show you that we will be executing constructor only once. So if I just have to run this, you can notice we are getting test object is created before test method. Only once test object is getting created, then it is invoking all the methods. Before all test, that is getting, that means before all annotation method is getting called, then before each annotated method is getting called, then the actual test is running. Fine. I hope you have understood how to change the behavior of an instance, the way it behaves behind the scene.